Okay, hello everyone. I welcome to all in our lecture series on fiber optics. In this lecture series, we are discussing these topics which are most essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. In our last class, we have been discussed classification of optical fibers. In this class, we are going to discuss losses in optical fiber. Okay, so let us start. Last class, we discussed classification of optical fibers. In this class, we are going to discuss losses in optical fiber. Here, as light travels through a optical fiber, so the loss of optical power is nothing but your attenuation. So if I'm going to define the attenuation of optical signal is defined as the ratio of optical output power from a fiber of length L to the input optical power. Let Pi is the optical power launched at the input end. Suppose this is your input end and this is your output end of this optical fiber, whose length is your capital L. So from this side, we launch the light source or signal with power Pi. So Pi is the optical power launched at the input end of the fiber. Then the power Po at the distance L down the fiber is given by this one. So Po, if I'm going to calculate Po, that means output power, then we can found this one, this much value. Po equal to Pi into e to the power minus alpha L. So obviously this is less than 1. This factor is less than 1. So obviously Po will be less than Pi. So this ratio Po by Pi is called as your attenuation of a optical signal. Right? Here alpha is called as the fiber attenuation coefficient. Its unit is your kilometer inverse. Now consider the natural logarithmic of this expression. Both the side, I am going to take the log of this expression. So here ln Po will be equal to ln Pi plus ln e to the power minus alpha L. That implies ln Po minus ln Pi equal to minus alpha L. That implies alpha L will be equal to, this minus will be multiplied with this side, so it will be ln Pi minus ln Po. Hence alpha will be equal to how much? 1 by L, and this will be written as ln Pi by P naught. Same thing it has been written. Okay, so by taking logarithmic both the side, we can get this much. So this represents your fiber attenuation coefficient. In decibel unit per kilometer, alpha is defined as, here just multiplied with 10 by L ln Pi by Po. If ideal fiber we are going to consider, then Po will be equal to Pi. So if I am going to put instead of Pi equal to Po, so this will be log 1 means 0. That means this alpha attenuation coefficient will be equal to 0. Same thing it has been written. You just remember, for ideal fiber, attenuation would be 0. Now we are going to go for two simple numericals. These two examples I taken from 𝒑𝒂𝒊𝒄𝒂𝒍 book, textbook of engineering physics, textbook of engineering physics. May you can consider for some other book for different type of numericals, but for the basic, these two numericals are most important. Here first, optical power of 1 milliwatt is launched, that means this is your Pi, into a optical fiber of length 100 meter L given. If the power emerging from the other end is your P 0.3 milliwatt, that means Po given 0.3 milliwatt, calculate the fiber attenuation. Fiber attenuation means alpha. Here fiber attenuation means alpha. Suppose only attenuation it is asked, that means you have to find out Po by Pi, but fiber attenuation means alpha you have to find out. So alpha we know that 10 by L. Either any one formula you can use. Either you can use the decibel per kilometer or only kilometer inverse. So here I used the second formula. So alpha will be equal to 10 by L log Pi by Po. So here 10 by L is given is your 100 meter, that means 0.1 kilometer, and log 1 milliwatt by 0.3 milliwatt, because these two units will be cancelled out. Finally we can found the answer will be 52.3 decibel per kilometer. Next question, what is the attenuation in decibel per kilometer if 15% of power feed to launching end of a 1 by 2 kilometer fiber is lost during the propagation? Okay, so in this question it is given that 15% of a power lost during the propagation. So if 15% is lost, so output is your how much? 85 percentage of pi, right? So here if I'm going to use this formula, then alpha will be equal to 10 by L log, suppose pi is your 100, po output will be 85 percentage, that means 85 is equal to 10 by, here length is your 0.5 kilometer, it is given that half kilometer means 0.5 kilometer, into log, this will be 1 by 0.85, right? So 10 by 0.5 log, here 1 by 0.85, you just calculate, it will be, I think it will be 1.176. You just calculate in your calculator 1.1176. So after calculation it can be found that the value will be 1.4 decibel per kilometer. Okay, so I think this answer is somewhat wrong, so do not follow this answer, you follow this answer, right? So here I am going to stop this lecture. In our next lecture we are going to discuss different mechanism of attenuation. Okay, so thank you so much for watching this video. Thank you.